Okay, bismillahirrahmanirrahim. Assalamualaikum and hi guys. So now we are at the very last topic for this semester, which is we are at chapter 10, application of differentiation. Okay, so in this video I will cover 10.1 extremum problems. Okay, so let's first go through about critical point and stationary points. So critical points of a function are points at which our derivative is equal to 0 or our derivative is undefined. Okay, so there are two cases for critical points. Okay. Also, as you know from your high school, derivative juga ataupun dy dx ni is actually your gradient. Okay, gradient of the graph. Okay, gradient of the function. Kecerunan kalau dalam bahasa Melayu. Okay, kecerunan. Okay, and dia points kan. So bila points dekat sini meaning that it must be coordinate. So dia mesti dalam bentuk x, y. Okay, ataupun C, FC, which is C tu adalah critical number. Okay, untuk koordinat X ni kita akan panggil dia critical number. Okay, X tu adalah critical number. Dan untuk nilai Y pula kita akan panggil dia critical value. Okay, untuk nilai Y dia kita akan panggil dia critical value. FC is critical value. Okay, so we have critical points. So X ni adalah critical number, Y ini adalah critical value. Okay, what else do we need to know? Stationary points. Okay, so stationary points adalah critical points yang mana untuk f prime x equal to 0. Okay, so basically if the f prime x is equal to 0, dia adalah critical points and also stationary points. Okay, alright. Okay, so let's see a few examples untuk kita punya graph yang mana critical points. Okay, yang mana diorang ada critical points. Okay, so first cases for f prime x equal to 0 ataupun kita punya kecerunan ataupun our gradient is equal to 0. So dekat mana point tu actually? So for the first graph, point tu actually dekat sini. Okay, so this is when your derivative is 0, tak ada kecerunan. Okay, the dy dx, the gradient is equal to 0. Okay, so for the second graph it is here, and then the last one it is here. Okay, so next one, the derivative is undefined. Okay, tak ada value ataupun tak ada nilai. So the first graph, the critical points is actually right here. Okay, dekat sini. Dia tak ada kecerunan. Okay, tak wujud kecerunan dia ataupun dia undefined. Okay, and then next one is for the next graph, dia dekat sini actually, kat tengah tu. Okay, kenapa? Sebab dekat tengah tu actually it's a very straight line. Okay, so bila straight line, bila korang cari derivative nanti, so as you know, korang pernah jumpa formula ni. Formula dia adalah y2 tolak y1, x2 tolak x1 untuk cari m ataupun untuk cari derivative. So untuk bila function yang ada straight line macam ni, actually nanti korang akan dapat per 0. Okay, sebab nilai x dia sama, dapat over 0. So bila over 0, dia jadi undefined. Okay, kita tak boleh bahagi dengan 0. Okay, dia jadi undefined. And then for the last case is over here. This is also when our derivative is equal to, the derivative is undefined. Okay, so now let's find the stationary points. Okay, jom kita try solve example ni. So dia kata find the stationary points and stationary values of the function. Okay, so stationary points, remember dia adalah critical points. Critical points untuk case yang mana f prime x equal to 0. Okay, so this is for so critical stationary points maksudnya kita nak coordinate when f prime x equal to 0. So kita kena cari coordinate dia, maksudnya points kan, kita kena cari x, y. And then last one dia kata dia suruh state the stationary values. So values, remember values adalah y. So kita kena state dia punya value of y. Okay, so kita dah ada function dekat situ. So our fx is equal to 2x cubed plus x squared minus 20x plus 5. So we are going to find the stationary points. Okay, so stationary points adalah when f prime x is equal to 0. Okay, so kita differentiate je macam biasa. So we're gonna get 6x squared plus 2x minus 20 equal to 0. Okay, so before insert into your calculator, you can actually simplify first. You can divide with 2. So you will get 3x squared plus x minus 10 equal to 0. Okay, so now use your calculator, insert the quadratic. So you will get 3x minus 5 and also x plus 2. So you're going to have two critical number. Okay, which is the first one, x equal to 5 over 3. And the second critical number is x equal to negative 2. Okay, so tak siap lagi sebab apa, kita nak points. Remember, kita nak points. So maksudnya kita kena cari dia punya y. So macam mana nak cari dia punya y? Just substitute. Okay, so when your x is equal to 5 over 3, kita akan cari dia punya nilai y. So y is your fx. So kita akan masukkan x kita into this function. Okay, so f 5 over 3, kita masuk saja. So we have 2 5 over 3 square cube plus 5 over 3 square minus 20 5 over 3 plus 5. So you will get negative 440 over 27. Okay, so do the same for x equal to negative 2. Okay, insert into the fx, so you will get 33. Okay, so now you already have the value of y, so you can write the stationary points. Okay, so and then you just need to do the conclusion. So stationary points are, so the first coordinate is 5 over 3 negative 440 27. And the other one is negative 2 33. So these are your stationary points. Okay, so are we done? Not yet, because remember the question asked us for the stationary value. Okay, so stationary value is the value of y, so just answer the question. You already have the value of y, so stationary values are negative 440 over 27 and 33. Okay, so we are done with the question. Okay. Okay guys, so now for example number 2. So the question asks us to find the critical number. Okay, so ingat critical number adalah nilai. Tengok balik nota korang, critical number adalah nilai x. Okay, so critical number. And then the coordinate of the critical point. So basically, soalan suruh cari nilai x dulu. And then you just have to find the x, y for critical points. Okay, so again remember critical points ada dua case. The first one is when your derivative is equal to 0. And the second one is when your derivative is undefined. You have two cases. Okay, so we need to consider both. Okay, kena consider dua-dua lah. Okay, tak boleh tengok this one saja, tak boleh lah, kena check dua-dua. Okay, so first of all, obviously we gonna differentiate dulu untuk cari f from x. Okay, so this is the function, so we are going to differentiate using the power rule. Okay, adakah korang masih ingat power rule bagaimana? Power rule. Okay, sebab kita ada function dekat dalam and we have power. So by using power rule, f prime x equal to, first dia punya power bawa turun, and then the function salin balik sebiji, but then the power will decrease by 1, so tolak 1, dia jadi negative 1 over 3. And last one kita akan differentiate yang dalam. So differentiate dalam we have 2x. Okay, so kita cantikkan sikit. So this one kita boleh gabung jadi 4x over 3. Wait, saya ingat pula 3, and then this one saya bawa turun, dia jadi x square minus 4 power 1 over 3. Okay, so untuk kita punya critical point, so we are going to consider the first cases. So the first case, our f prime x will equal to 0. Ni first case untuk critical points. Okay, so just equalkan dengan 0 je. So 4x over 3x square minus 4 to the power of 1 over 3 equal to 0. So ni buat pindah sebelah hilang. So we have 4x equal to 0. So x equal to 0. So we get our first critical number. Okay, so the second case is when our f prime x is undefined. Okay, so macam mana nak jadikan function kita ni undefined? Our f prime x ni undefined. Okay, so remember, dekat bawah ni ataupun our denominator cannot be 0. So untuk the f prime x undefined, kita akan let yang bawah ni equal to 0. Yang bawah ni kita akan equal to 0. Okay, untuk undefined. So the function, the f prime x will be undefined when the denominator, which is 3 multiple x square minus 4 to the power of 1 over 3 equal to 0. Okay, so 3 buat pindah sebelah hilang. Okay, nak hilangkan the 1 over 3, kita akan power to power 3. So power 3, dua-dua belah, automatic hilang. So x square minus 4 equal to 0. X square equal to 4. X sama dengan plus minus square root 4, which is plus minus 2. Sorry. Okay. Alright, so we have 3 critical number. Okay, let's cari critical number. So tak siap lagi kita nak point. So we need to find your y. Okay, so cari dulu y. So when x equal to 0, so masukkan kita punya critical number dalam function asal untuk cari your y. Okay, so saya masukkan terus. Okay, so you will get 2.52 dekat sini. And then untuk negative 2, you will get 0. And for x equal to 2, you will also get 0. Okay, so now baru buat conclusion to answer the question. Okay, so the first one dia minta critical number kan. So just write critical numbers. are 0, -2, and 2. And then the second part of the question, critical points. So kita ada critical points ada 3. So the first one is 0, 2.52. Second one, -2, 0. And last one, 2, 0. Okay. So critical points are 0, 2.52, -2, 0, and 2, 0. Okay. Done. Okay. Okay guys, so now we are at the last question. Okay, untuk critical points, so dia suruh cari find the critical points of the curve. Okay, so again remember the same thing like question number 2. So you remember critical points are points where when first case is when f prime x is equal to 0 and the second case is when prime x is undefined. Okay, so same as before, first you need to differentiate first. Okay, so how do we differentiate this one? First, to make your differentiation become more easier, I'm going to bring all this to the top. Okay, x squared minus 9 power -1. Okay, so instead of using the quotient rule, okay, instead of using this rule, you're going to use the power rule only. Okay, kita akan pakai power rule je, lagi mudah daripada korang pakai quotient rule. Sebab tu saya bawa di atas. Okay, sebab saya nak simplekan saya punya differentiation supaya tak banyak kerja. Okay, so I'm going to differentiate. So f prime x using power rule, 2 masih ada, power bawa turun, salin balik sebiji, power dia berkurang 1, and last one, differentiate the differentiate the function inside. Okay, so saya simplekan. This one boleh darab, yang ni boleh bawa turun. So dia jadi -4x over x squared minus 9 to the power of 2. Okay, so kita buat macam tadi. So the first case is when our f prime x is equal to 0. Okay. So just -4x over x squared minus 9 to the power of 2 equal to 0. So -4x equal to 0. So x equal to 0. So this is your first critical number. And next one is when your f prime x is undefined. Okay. So remember like the previous question, macam mana nak jadikan dia undefined? Just jadikan the denominator is 0. So x squared minus 9 power 2 equal to 0. Square root both sides. We're going to have like this. X squared equal to 9. So x sama dengan plus minus square root 9 is 3. Okay, so we have 3 critical number juga. Okay, so now kita nak points kan? So bila points, kena cari nilai y dia. So when x equal to 0, f0 masuk sahaja dalam ni. Masukkan dalam ni. You will get -2/9. Okay, so ni special sikit sebab apa? Untuk the next critical number, so let's try masukkan -3 apa yang jadi. So f -3 kita akan masuk dekat function ni kan. So dia jadi 2 over x square over minus 9. Okay, so yang bawah tu perasan tak? Dia 9 tolak 9. So dia jadi 0. So 2 over 0 tak boleh kan? So the function is undefined. Tak ada value lah basically. Okay, sama juga dengan when x equal to 3. Kalau korang masukkan, dia dapat 0 dekat bawah. Okay, so tak boleh juga. So this is also undefined. So maksudnya since these two are undefined, meaning that you only have one critical point lah, which is this one. Okay, so don't forget to make conclusion. So the critical point is only one, which is 0, -2 over 9. Okay, settle. Okay guys, so now we are at the first derivative task. Okay, so suppose that c is a critical number. So remember critical number tadi adalah nilai x. Okay, so how do we get the value of x? We just let our f prime x equal to 0. And then from this we will get a value of x, which is, this is our critical number. Okay, so now we are going to check whether the function has relative maximum at c, or has relative minimum at c, or no relative extremum at c. Okay, so we are going to use the first derivative test to check either it is this one, or this one. So how do we use the derivative test? Kita akan pakai table. So this is the table. Okay, we're going to have range, test value, sign f prime x, and shape. Okay, so basically what will happen is first we are going to write the interval or range. Okay, range is the interval, it's the same thing. And then we're going to insert any test value, which is value of x, and it must be within the range. Okay, mesti dalam range. And then we are going to substitute the value of x dekat sini dalam f prime x. So then we need to check whether we get positive sign or negative sign. Okay, so from this sign we are going to draw two shapes. Okay, so the first shape is like this. So this is for plus. Let's say this is plus. So this is the shape. Okay, and then the second shape will be like this. So this is for negative. So let's say here negative. This is the shape. Okay, so we are going to use the table. Okay, so basically what I'm going to show you. Okay, so the first case, if let's say you have this shape and then this shape. Okay, so this is the visualization. Okay, so you will get maximum, relative maximum. Okay, and next one, if you have this shape and then this shape, you will get minimum, relative minimum. Okay, this one. And then let's say you have this shape and then this shape. So for example, the first shape will be like this and the second shape will be like this, or the first shape like this or the second shape like this. So for these two cases, you will have no relative maximum. Okay, no relative extremum. Okay, so basically we are going to have either this one, or this one. Okay, so alright, so now let's do the example. Okay guys, so I'm going to do number 2. Okay, so we are given function fx. So the question asks us to find all relative maximum and relative minimum point. Okay, so basically the first step is we are going to find the first derivative first. Itulah. Okay, first derivative, so we are going to differentiate. Okay, macam biasa, so we'll get 12x squared plus 18x minus 12. Okay, and then untuk cari relative maximum and minimum, remember we need to have critical number. Okay, we need to have critical number. So nak cari critical number macam mana? Kita kena let our f prime x equal to 0. Okay, so f prime x is equal to 0. So 12x squared plus 18x minus 12 equal to 0. Okay, so this one also you can simplify first before masuk dalam calculator. So we have 2x squared plus 3x minus 2 equal to 0. So you will get two factor yang cantik. The first one is 2x minus 1. The second one is x plus 2. Okay, so we have two critical number, which is the first one is x equal to half. The second one is x equal to negative 2. Okay, so we have two critical values. Critical number, sorry. Okay, so since final answer nanti mesti ada points kan. So remember, points adalah coordinate. So korang cari dulu coordinate dia. Okay, so saya cari kat belah kanan. Wait, saya cari kat belah kanan. So when x equal to half, kita nak cari y kan. So kita akan masukkan balik dalam function original. Okay, so f half masuk je. 4 1 over 2 power 3 plus 9 1 over 2 power 2 minus 12 1 over 2 plus 13. So you will get 39 over 4. Okay, so the first point yang pertama adalah 1 over 2, 39 over 4. This is the first point. Okay, the second point pun sama, kita akan masukkan negative 2. So ini korang masukkan sendiri, so you will get 41. So the second point is negative 2, 41. Okay, ada 2 point. So now we are going to check these 2 point whether they are max, minimum ataupun no relative maximum using the first derivative test. Okay, so by using first derivative test, okay, using first derivative test, so we are going to use table. Okay, so table ni saya lupa nak lukiskan untuk korang, so sorry, so korang lukis sendiri. Okay, okay, so macam mana nak tulis ni? First dia punya range. Okay, so range kita akan tengok value critical number yang kita ada tadi. So we'll start with negative infinity, and the next one is negative 2, 1 over 2 and infinity. Okay, so it's just the same like table of sign, macam table of sign juga. So just letakkan saja all the values. Okay, and for this one we gonna use all open bracket. Okay, memang semua open bracket. Okay, and then test value ini nilai x yang dalam range. Okay, so saya masukkan apa-apa saja. So let's say negative 3, and then here 0, and then sini let's say 1. Okay, so I substitute. So next step is I'm going to substitute this into our f prime x. Okay, bukan fx ya, kita akan masuk dalam f prime x. So masuk dekat sini. Okay, kita masuk dekat sini untuk tengok sign dia. Okay, so masukkan. So you will get symbol dia adalah plus, minus, plus. Okay, then we are going to draw the shape. Remember, this one is for positive, this one is for negative. So shape dia akan jadi positif macam ni, negatif macam ni. Okay, next one kita akan check dia positif ke, negatif ke ataupun tak ada relative maximum. So macam mana korang nak check? Okay, so this is the value of x. Okay, so tengok the first one untuk ni, value of x dia. Shape dia macam ni, lepas tu macam ni. Okay, so dia adalah maximum. Okay, so sini nilai ni adalah maximum, relative maximum. Okay, untuk yang ni pula 1/2, so shape dia macam ni, lepas tu macam ni. So dia adalah minimum, relative minimum. Okay. Okay, so dah tahu, dah check dah dia maximum ke minimum, don't forget to conclude. Okay, so the relative maximum, maximus pula. Maximum is, so ni dia punya maximum kan, koordinat dia adalah ni, negative 2, 41. And relative minimum is at, so ni ni minimum kan, so minimum point dia 1/2 yang ni. Okay, so masukkan sahaja 1/2, 39/4. Okay, settle part A. So this is how you use the first derivative test. Okay, so soalan tak habis lagi guys. Jangan tertinggal soalan So the second part of the question dia kata state the interval. Basically dia suruh state the range lah. So range yang mana function dia increase and function dia decrease. Okay, nak tahu senang sahaja. So tengok dekat dua interval ni shape dia macam ni kan. So bila shape dia macam ni positif kan. So maksudnya untuk this range dia akan increase. Untuk decrease pula obviously this one. Okay, so dia suruh minta range dia kan. So untuk increasing, range dia adalah negative infinity sampai negative 2 and 1/2 until infinity. And then untuk decreasing pula, function kita akan decrease dekat mana? Dekat interval negative 2, 1/2. Settle. Okay? Okay guys, so now we are at the last part of the video. So tadi kita belajar first derivative test kan, nak check whether our points, our critical points tadi adalah maximum atau minimum. Okay, so sekarang kita nak pakai second derivative test pula. Okay, so second derivative test is much more easier. Okay, lagi mudah sebab apa? So the same thing. So suppose that C is a critical number of a function. Okay, so macam mana nak dapat critical number ataupun nilai X? So sama sahaja step dia, our f prime X will equal to 0. So and then from here you will get your X. Okay, so value of X ini adalah your critical number. Okay, so lepas tu macam mana kita nak check dia maximum ke minimum? Okay, kita akan differentiate kali kedua. Okay, we differentiate again the function. So let's say our second derivative is greater than 0. So maksudnya fx kita relative minimum. Okay, and kalau second derivative kita less than 0 pula, our function has relative maximum. Okay, alright. But let's say if your second derivative exactly equal to 0, maksudnya tak boleh. Test fail. So bila fail, korang kena pakai first derivative test. Okay, tak boleh. So dia mesti either greater than 0 or less than 0. So greater than 0, minimum. Less than 0, maximum. Okay? Alright, so we are going to do just one example because this is very simple. We are going to try number 1. Okay, so by using second derivative test, find the relative extremum. Okay, so first step, obviously, we are going to differentiate. Okay, differentiate macam before. So 3x squared minus 6x minus 24. Okay, so nak check relative maximum, extremum, you must have critical number first kan. So untuk critical number, we just let f prime x equal to 0. So this one also you can simplify before insert into your calculator. So we'll have x squared minus 2x minus 8 equal to 0. So x plus 2, x minus 4 equal to 0. Okay, so we'll get two critical number, x negative 2 and x equal to 4. Okay, so again, remember, we are going to get the points, right? Points. So we need to find the value of y first. Okay, so when x equal to negative 2, f negative 2, so just insert your value of x into the original function. You will get 60, so the point will be negative 2 and 60. This is the first coordinate, and the second one is f4, you will get negative 48. Okay, so the second point is 4, negative 48. Okay, so these are the two critical points. So now we are going to check which one is maximum, which one is minimum using the second derivative test. Okay, so nama pun second derivative test kan, so you just need to differentiate again first. Differentiate again, so we are going to differentiate this one. You will get 6x minus 6. Okay, so then what you are going to do is you are going to substitute the critical number that you get. This one and this one kita akan masukkan. So first when x equal to -2, so f prime prime -2, 6 -2 tolak 6. So we get -18. So -18 is less than 0. So tengok balik, bila less than 0 dia adalah maksimum. Okay, so dia maksimum. And bila x equal to 4 pula, so kita masukkan 4 dalam second derivative. 4 minus 6 we get 18, positive 18, which is greater than 0. So bila greater than 0 dia minimum. Okay, so dah tahu maksimum minimum, boleh terus conclude. Okay, so maksimum kan, maksimum dia adalah nilai x equal to -2. So this is the point. Okay, so the relative maximum is coordinate negative to 60, and the relative minimum is, so ni kita check tadi minimum kan, so minimum maksudnya coordinate x equal to 4, so this is the coordinate. Okay, 4 -48. Okay, settle. This is very easy. Okay, second derivative sangatlah mudah. Okay, so saya go through summary sekejap. So we have two tests. Okay, the first derivative and second derivative test to check whether our critical points is relative maximum, relative minimum, ataupun dia has no relative extremum. Okay, so untuk first derivative test kita pakai table tadi. Kita pakai table. So final answer korang sama ada korang dapat bentuk macam the first one. So ni maksudnya dia minimum. Ataupun korang dapat bentuk macam ni. So ni adalah maksimum. Ataupun korang dapat dua bentuk yang macam ni ataupun macam ni. Dia tak ada maksimum minimum. So basically dia has no relative extremum. Okay, korang kena check dekat final shape korang. Okay, untuk second derivative pula kita akan differentiate kali kedua. So bila differentiate kali kedua is greater than 0, dia minimum. Okay, kalau dia less than 0, dia maximum. Kalau dia exactly equal to 0, korang kena pakai first derivative test. Okay, sebab test dia maksudnya fail lah, tak boleh equal to 0. Okay, alright, so we are done for the day. Okay, that's it guys.